Hi, and welcome to Lesson 17 in Distance Learning of Algebra 1. If your teacher is Ms. Boatwright, Ms. Reynolds, Mr. McCrae, Mr. Strickland, Mr. Still, or Mr. Yates, you're in the right place. I remind you, you can stop this video at any time, you can rewind it, or you can fast forward it. And once you get to the end of our video, you get the joke of the day. If you would like to make a submission for the joke of the day, please email it to your Algebra 1 teacher. Today's learning target is I can understand the properties of parabolas in real-life problems. Parabolas and soccer. The Portland Timbers have been awarded a free kick. It's from 27 yards away, and midfielder Diego Valeri has already scored from this range, so he seems like the obvious choice to take the kick. But Valeri is known for his low, powerful shots, and the Seattle Sounders defense sets up a wall that will need to be kicked over. The Timbers coach decides to have striker Felipe Mora take the kick because he has been more consistent with a higher kick that would clear that wall. Both players' shots landed in the back of the net 3 yards from the goal line. They ask us 3 questions. How can we represent this on a graph? What information will be important? And how should we set up our axes? Well, how do you represent a soccer kick on a graph? Well, you're probably thinking, this is parabola week in algebra, so I'm guessing a parabola, Mr. Yates, and you would be right about that. A parabola would be a great way to represent this on a graph. So what is our important information? Well, how far and how high the kick is would be important, right? How should we set up our axes? In our last lesson, we used distance as the x-axis and we use height as the y. So perhaps we should stay with that winning combination. Here is a graph of our 2 kicks, Mora's and Valeri's. And obviously they are parabolas. They ask us some questions. How far was each kick? How high was Valeri's kick? And how high was Mora's kick? Before I continue, I would like you to stop the video and think about each of those questions and write down an answer. All right, I hope you stopped the video and you wrote down some answers. It asks us, how far was each kick? Well, if we look over here, it looks like each kick made a distance of how many yards? If you said 30, you are correct. And then it says, how high was Valeri's kick? Well, here is Valeri's kick. How high is it? If you said 3 yards, then you would be correct. And then it asks us, how high is Mora's kick? Here we are. If you said it was 9 yards, well, you're today's winner. They ask us a couple of more questions. What do the roots represent? And what does each vertex represent? So you might be going, roots? I don't see any trees. Here's a root where the parabola crosses or touches on the x-axis, and here's the other one. What do those 2 dots represent? And if you think about it, our first root represents where the kick starts, right? The beginning of the kick. And our last one over here is the end of the kick. Now it says, what does each of these vertex represent? Our vertex, please remember, are right here for Mr. Mora and right here for Mr. Valeri. And if we look at the parabola, it's what? It's how high they are, correct? It's also the middle. It's where it changes from going up to going down. So let's just write, how about this, the highest point of each kick. Sorry about that, I got a little mess up over here. But it's the highest point of the kick. Now, I want you to remember the vertex form, y equals a times x minus h squared plus k, and that the vertex is h and k. The way that translates for us is, for instance, on Mr. Valeri, 15.3 is his x and y, which is the equivalent of h and k. All right, Mr. Valeri's vertex is 15.3, so his x is 15, that means his h is 15. That goes right there. We've just did the h, and now we're going to do the k. K is what? 3? You're right. Mr. Mora, he got a little higher, but it was just as far. His vertex was 15.9. Sketching a graph in the vertex form. All right. What do we know? A corner kick in a soccer game can be represented by the equation y equals negative 0.0347 times x minus 12 squared plus 5. And that vertex form tells us a few things. One of the things it tells us is a is negative, so it goes down. And that the vertex is 12.5. Also, we know that parabolas are symmetrical. That means they're equal on both sides. We can run a line right through the middle, and one side would be a mirror version of the other. They're always the same on both sides of the vertex. So with that knowledge, we're going to go ahead and try and graph this. What do you think we should start at? Stop the video and think about it. How am I going to graph this? If my vertex is 12.5 and it opens down and it's symmetrical. Hopefully you did stop the video and you thought about it. A starting point could be at 0, obviously, or it could be at the vertex, which we know is 12.5. X is 12, y is 5. So here is 12, here is 5. That would put our dot right about there. Again, it doesn't have to be a work of art, but I encourage you to write on your piece of paper 0 to 25 along the bottom, and 0 to 7 or 8 on the top, and then put a dot at 12.5. Now we know that parabolas are symmetrical, and also we know that a kick comes from the ground, so we're going to go from 0 to the vertex. Sorry, my sketcher won't let me sketch to 0 there on my slide, but if you could, you would see a line that goes right to 0. Now, we know that they're symmetrical, so we're going to go right to, what is 12 plus 12? If you said 24, you got it right. There's our parabola. Again, I wish my machine would let me shade in from 0 to, that looks like 3, but it won't. That's a reasonable facsimile of what we're talking about here for a vertex form graph. And we did it with basically 3 pieces of information. We knew that it was negative, A, so that it opened down. We knew that the vertex was at 12.5, so we made it our high point. And we knew that parabolas are symmetrical, so that a parabola would be equal on both sides. We could, technically speaking, do a dotted line right down the middle and they would equal to both sides. In summary, parabolas might have the same distance, like when the soccer ball was kicked to and from where it landed, but they could have different heights. Parabolas are always what? And the what is always in the middle. If you said that the vertex is always in the middle, that you are correct. And fancy word, but it just means it's equal on both sides, and you can run a line right through the middle of it. Symmetrical is what they're looking for here. Parabolas are symmetrical. What next? Parabolas in basketball. Log into student.desmos.com for a fun lesson where you just get to guess on hoops, whether a shooter makes it or not, based on the arc of their shot. Try practice work 17, try Google homework number 17, or watch our next lesson, video 18. Here is today's joke of the day. What starts with an E, ends with E, and only has one letter in it? An envelope. That's all for today. Thank you very much. Remember, if you have a suggestion for joke of the day, email your Algebra 1 teacher. We'll see you next time.